Hello everyone, this is Sergio here, and I'm going to be showing you guys how to do and solve the area of a velocity over time graph, and I'm going to explain what it means in context of any questions your teacher might have asked of you. Hello everyone, it's Sergio, and I'm going to be showing you how to solve a velocity over time graph. Or not, because this thing is freezing. Oh, that's why. Hey, hello. Hello everyone, it's Sergio here, and I'm going to show you guys how to solve and find the area of velocity over time graph and explain what it means in context. So first we have to make a graph for us to get our information from. So I'm going to say this velocity here is going to be miles per hour, and this time will be, let's just say hours. So that defers real quick there. So these are our units. Now we make our increments here. 1, 2, 3, 4, 5, 10, 20, 30, 40, 50. So let's say our data is here, and it's just 40 miles per hour for all 5 hours. So we just have a constant velocity. The area follows the same rules of any other area of a rectangle, because we have this imaginary line here connecting this. So area is going to be base times height. In this case, means that our area is going to be our base, which is our time in hours, so 5 hours. Alright, because this goes here. This is our height here, multiplied by our velocity, which is 40 miles per hour. And so what we're going to be doing is we're going to be using the basic sort of grid format we used when we were doing conversions back in chemistry. And if you didn't do this sort of thing, it's pretty much just an extended fraction, but with extra vertical lines separating the important pieces of information. So we have 5 hours, which is just on its own, so you don't need anything in the denominator, because ideally we'd understand it's just 1 times 40 miles per hour. So it's fairly simple here. The hours cancel out, so you end up with 5 times 40, which equals 200. And what's our unit? It's miles. So we bring miles over. There's just not space to write it there. So our area in this case would end up equaling 200 miles. And if you think about it for a minute, what does the 200 miles represent? It represents the total distance covered because of our speed and, or rather our velocity, and the time we took. So the area represents the total distance covered relative to our velocity and time. So in other words, if this were some sort of regular linear graph where you're saying in 1 second I traveled 40 miles per hour, or I traveled 40 miles in 1 hour. In 2 hours I traveled 80, 3 hours 120, right? So you have a slope there. Whatever your cutoff point is, which in our case is our 5 hours, whatever that cutoff point is represents the total distance you traveled. So basically this area is just another way to represent the total distance covered. I hope you're able to learn something from this video, and if you'd like, please feel free to leave a comment suggesting what sort of how-to video I should do next, and please subscribe, leave comments describing how I can make this better or worse, and if you liked it, like the video. And so I hope you guys have a great day, and I'll see you guys next time.
When the devil finished, Johnny said,
"Well, you're pretty good, old son. But sit down in that chair right there. Let me show